Okay, that last video was really a sort of a little lesson on logs. I know sometimes they be confusing, and I've taught it enough that hopefully the way I explained it, you can begin to sort of understand and pick up some tips on how to start doing how to work with logs and exponential equations. So now let's look at 20 and see what these problems are like. 20 says find A so that the graph of f of x equals log base A of x contains the point 15,2. So basically, they're giving us a function, and it's a log function. So they say f of x equals log base A of x. And right away, I'm going to change f of x to y just because usually it makes more sense to me and I can understand it. Basically, they're saying they've got a point this point 15,2 works for this equation, and they're saying if we give you this point, figure out what the base is. So let's just go ahead and plug in 15 for x and 2 for y into this and see if we can somehow figure out what a equals. So y is actually 2, x is 15. So if I plug in this point, I end up with 2 equals log base A of 15. And they're saying, what is A equal to? Well, just like I explained in the last little, it's almost like a little lecture. Here's a case where I'm trying to sort of solve a log equation. In this case, I'm trying to figure out the base. I don't know how to do it, but you know what? The rule is going to be, if you're ever trying to solve a log equation and you're stuck, convert it to an exponential equation, and most of the time you can solve it. So let's take this log equation and let's rewrite it as an exponential equation. And this is where we use a little circle method. This is the easiest way I found to do this. You start with the base, so A, you go across, A squared equals 15. I can now solve this for A, right? A squared equals 15. What do I do? Take square root of both sides. End up with A equals square root of 15, and you're done. All right, not too bad. That was quick. Problem 21. All right. Now, 21 and 22 are, let's talk about these for a minute, because these are both actually where they give you a graph of a log equation, and then they give you like 8 different possible equations, and you have to determine which one is correct. And what I'm going to suggest is to do the same thing we did a little bit ago with graphs, where if you're given a graph, you can sometimes use process of elimination to start eliminate equations and figure it out. So for instance, I'll just show you this. Here's the graph they give you. They're saying this is some kind of graph of a log function. And they give you 8 possible equations, and they say, which one is this? Now, in order to do this, we have to talk a little bit about a few more logs, sort of special logs. And you have to sort of remember these in order to do these kinds of problems. If you can't remember them, then it makes it even more difficult. Let's talk about some special logs. What do I mean by this? For instance, log base 10 of 1. Let's figure out what the log of 1 is. 1's a pretty common number. Let's just call it x. Common log 1 equals x. What is x? What is this equal to? Let's do it. Let's convert this to an exponential. There's really a 10 there, right? So 10 to the x equals 1. Now if you look at this exponential equation, what does x have to be? 10 to the x equals 1. We know x has to be 0. It's very important to realize anytime you take the log of 1. Here I put base a, meaning a can be any base. It can be base 2, base 5, base 10, base e. Doesn't matter. It's pretty important to remember anytime you take the log of the number 1, it's always 0. Just for fun, let's see what happens. How about, let's see what happens when you take log of 0. Maybe that's important. So log of 0 equals x. What does this equal? Once again, I'm going to convert this to an exponent to see what happens. So there's really a 10 here. 10 to the x equals 0. So when you ask ourselves, what number could I put in for x where 10 to the x equals 0? As it turns out, if you think about it, or maybe you never thought about it, it's actually impossible. There's no number I can plug in for x that's going to work here. Which means, you can remember this, it helps. Anytime you take the log of 0, I don't care what the base is, base 2, base 5, base 10, whatever, you can't really do it. So if you're ever working a problem, and all of a sudden you end up with the log of 0, you can just stop and say, hey, we're done. The log of 0 is undefined. I can't do any more math. As a matter of fact, let's just do one more special one. What might happen if you try and take the log of like a negative number? Common log of -5, what does that equal? All right, for all these problems, you do it the same way. You convert it to an exponent. 10 to the x equals -5. So once again, what number can I put in for x because this would cause 10 to the x equal -5? Once again, it's impossible. So here's another sort of important rule you need to learn. Anytime you take the log of like a negative, any kind of negative number, it's undefined. So it's interesting. You can't take the log of a negative number, it's undefined. You can't take the log of 0, it's undefined. And the log of 1 is 0. So those are 3 things that can be pretty important. And I brought those up because we're going to use this information now to figure out these graphs. So let me show you how. Hopefully this won't be confusing. Sometimes these graphs are the worst thing about logs. Figure out these graphs. So here is my graph. Once again, you can see y is here and x is here. Let's pick a point. Look at this point right here. This point right here is x is -1 and y is 0. So I'm going to start looking at some of these equations and see if I plug in -1 for x to see if the y is actually 0. And maybe I can get rid of some of these equations. For instance, A, if I plug in -1 for x, so I have negative log base 4 of negative x is -1. So it's really 1. The negative log base 4 of 1. Well, just a minute ago, what did we say about when you take the log of 1? It always equals 0. So a negative 0 is 0. Actually, it's 0. That might be my equation. When I plugged in -1 for x, y ended up being 0. But I can't stop. Maybe there's another equation or two that would also work, so I have to keep going. How about this one? If I plug in -1 for x, I get 1 minus log base 4 of -1. You know what I do right away? What am I doing here? Trying to take the log of a negative number. I can't do it. That's definitely not going to be the equation. How about this one? When I put in -1 for x here, I get log base 4, -1 minus 1, log base 4 of -2. Once again, I can't take the log of a negative number. The next one, negative log base 4 of x. Negative log base 4 of -1. I'm taking the log of a negative number. All right. These equations are dropping like flies. How about this next one? I plug in -1 for x. Log base 4. 1 minus a -1, which is really 1 plus 1. Well, you know what? Log base 4 of 2, I know it does not equal 0, because I know the only way you get 0 is if it's log 1. So it's not this one. Log base 4 of -x, a -1, which is 1. Log base 4 of 1, it's 0. Okay, that's what I'm looking for. When is y 0? So there's another possibility. So far I've got two equations that this point works for. All right, let's do this one. Log base 4 of x. Log base 4 of -1 minus 1. I'm taking the log of a negative number. Can't do it. And actually, this last one, if you plug in -1 for x, you're taking the log of a negative number. All right, so I've narrowed it down to A and D. Now I have to determine which one of these is correct. Let's go ahead. When x is -5, I notice y is a positive. So let's put in x equal -5 and see what these two equations look like and see. Actually, yeah, that's fine. So A, when x is -5, y equals the negative log base 4. When you put in -5, a negative is positive. So this is saying, now log base 4 of 5 is going to be a positive number, but the negative out front makes it negative. But if you look here, for negative 5, y is positive. I don't think this one's correct. Let's see if D works out. What happens when I plug in negative 5 for D? So this one was A, and this one's D. Y equals log base 4. A negative x is a negative negative 5, which is log base 4 of 5. That's going to be a positive number, and it ends up staying positive. So this is a negative number for equation A, but this one ends up being a positive number. Therefore, that's why the answer is D. All right. So let's do one more, number 22. See if we can figure this one out. Same kind of thing. Let's see if we can be smart about it. Once again, let's pick this point right here. Looks like that point, 1, 2, 3. Looks like x is 4 and y is 0. See if that helps us at all. Now remember, so let's go to A. Let's go ahead and start. Then I'll remind you of a very important log rule. So negative log base 4, x is 4 of 4. What does this equal? Remember that special rule about logs? If we're taking the log of a number, and that number is the base of the log, what does this whole thing equal? Equals 1. So this whole thing is negative 1. Well, that's definitely not correct. How about here? Log base 4, negative x, which means negative 4. What have I got here? I'm taking a log of a negative number. That can't be correct. How about this one? Log base 4, 1 minus x. 1 minus 4 is minus 3. I can't take the log of a negative number. Y equals log base 4 of x. So this is log base 4 of 4 minus 1. Log base 4 of 4, that special rule says it's 1. 1 minus 1 equals 0. Boom. That actually works. So far I have one equation that works for that point. I got to check the rest of these. This one would be 1 minus log base 4 of 4. Log base 4 of 4 is 1. 1 minus 1. Wow, there's another one that works. 2 in a row. How about this one? Log base 4 of 4. Special rule says that's 1. But I want y to be 0, so that's not it. Negative log base 4. Negative x, which means negative 4. I can't take the log of a negative. Last possibility. Log base 4 of x minus 1. 4 minus 1, so log base 4 of 3. It's definitely not 0. So once again, I've narrowed it down to 2 equations. Either G or B. Now let's look, for instance, let's look when we can do one of two things. We can look to see when x gets very small, when x gets close to 0, or we can look when x gets big. How about, let's look, see if what happens when x gets very small, almost 0. So let's look at G. If x is very, very small, so for G, if we think about this, when x is very, very small, this number becomes very, very small, And you can see y ends up being a negative number. But you notice here, y is positive. I don't think g is correct. Let's see what happens when we think about b. So b is y equals 1 minus log 4 of x. If x gets very, very small, this number also gets small. 1 minus a small number is basically 1. And I think that makes sense. So that's why it's B. All right, once again, process of elimination. Not my favorite kind of problems, but I have to be able to figure them out. All right, so I think those are all the graphs for a while. So the next video we'll talk about actually solving some more of these log equations.